Hello, welcome to our lesson on mensuration. We are going to look at trapezium, or the American would say trapezoid. All right, so we are going to look at the area and perimeter of a trapezium. So, what is even a trapezium or a trapezoid? Okay, so when you see the word trapezoid, it's also the Americans that normally use the word trapezoid. Okay, so we are going to look at the area and perimeter of a trapezium. What is even a trapezium? Trapezium is a quadrilateral, a four-sided figure, okay, where two opposite sides are parallel but not equal. Okay, two opposite. So trapezium can be like the two opposite sides. This line being parallel, this side being parallel to this side, but not equal. So this is how A, B, and then B. So this is how a trapezium can look like. This is a typical example of a trapezium. All right, and as we said, the two sides here, okay, they are parallel, but they are not the same. So AB, length AB is parallel to the length DC, okay, but not equal. Okay, what about this side? This side too, it can happen that sometimes they are the same, sometimes they are not the same. Even sometimes one of the side here becomes the height, which will be a right angle. So with even trapezium, we have let me talk about three types of trapezium that we have. We can have a trapezium, okay, where the side here and the side here are the same. Okay, though these two sides are parallel, the opposite sides are parallel, but this side is the same as this side. Okay, when it happens, we call it isosceles trapezium. Trapezium where these two sides, okay, these two slopey sides are equal. Okay, it can also happen that they are not the same. This side and this side are not the same, they are different. Okay, so that one too we say scalene. We also have scalene trapezium. Scalene trapezium. This side and this side are different, though these two sides are parallel. All right, and we can also have a type of trapezium where one side is a right angle. Okay, trapezium can also be like this. Where here is 90 degrees, so this is a right angled trapezium because it was right angled trapezium. So these are the types of trapezium we can actually have. All right, it can happen that this side will be 90 degrees. That becomes the height of the trapezium actually, and it's a right angled trapezium. This side is the same as this side, isosceles trapezium, and then these two sides are not the same, so scalene trapezium. All right. Okay, so now let's look at the area and then the perimeter. All right, so area of a trapezium. Okay, so if you want to calculate the area of a trapezium, we say the area of a trapezium can be calculated as what? Half multiplied by sum of the parallel sides multiplied by the height. Okay, so if I look at this trapezium there, what are the parallel sides? That is the DC and the AB. So I can say half times AB, okay, say sum plus BC times the height. What is the height? So the height can be like this. So you take note. The height is always perpendicular to the base, or you can even have the height like this. Okay. The same thing. Okay. So this can be our height times the h. All right. So that is the area of a trapezoid. So let's assume that if here is A, here is, let's say, B, C, and then D. We have to label all the part A, B, C, and D. Then here we can have times. What is the sum of the part A plus C? Okay, that's what, times the H. That is what we are talking about. So half times A plus C, sum of the parasite times the height. So that is the area. Okay, area. Let's look at the perimeter. So perimeter of a trapezium. So we are privy to perimeter. What is perimeter? The sum of the distance around the figure. So if I go around, so I mean this side plus this side plus this side plus, so A plus B plus A plus D. So A plus B plus C plus D. So that is the perimeter of the trapezium. Alright. So this is about the area and then perimeter of a trapezium. Okay. Let's solve some few questions and then we close our lesson. Alright. Okay, so let's look at the questions. The area of a trapezium is 210 centimeters squared and its parasites are 24 centimeters and 16 centimeters long. Find the perpendicular distance between the two parasites. Alright. So what is area of a trapezium? Half times sum of parasites times the height. Okay, so this is our formula. All right. So now you have what? The area as 210. So 210, that is the area, is equal to half times the sum of parasites. We are giving the parasites at what? The parasites are 24 and 16. So 24 plus 16 times h, which is the height. All right. So with this, if you like, I multiply 2 by 210, and 2 by 210 will give us what? 420. All right. Then the numerator is left with 1. Then we add these two. Okay. And you have 24 plus 16. 24 plus 16 gives us 40. And then we multiply by the h. So we have 40h. Okay. So 2 multiply here. And then 1, here is 1. So 24 plus 16 will give us what? Will give us 40 times 1, which is 40. Then multiply by the h. So what will be our height? Our height is going to be 420 divided by 40. And that will give us 10.5. So our height is 10.5 centimeters. So simple. So the height of the trapezium is 10.5 centimeters. 10.5 centimeters. All right. Let's go to the number 2. Number 2. We have the diagram here. This is a trapezium. Here is 10 centimeters. The height is 30 degrees. And then we are asked to find the area and perimeter of the diagram. Okay, so what is the area of the trapezium? Half times sum of the parasites. What are the parasites? AB and then FC. From F to C. Multiply by the height. So the height is 5. So we know one of the parasites has 10, but we don't know from here to here. So that is what we have to work with. Okay, so let me write the area down. So we know that area of a trapezium okay, or area of the trapezium is half times sum of the parallel sides. Or we can say area of the, so that we are referring to this trapezium. Area of the trapezium is half times or sum of the parallel sides. What are the parallel sides? AB, side of AB plus FC. Then we multiply by the height. Okay, so the height was given as what? The height can be AE or BD. Okay, so let me use the variable AE. So that when I'm writing, I'll just substitute there. So the height is either AE or BD. So half times the sum of the parallel sides, that is AB, and then what? FE. These two sides are parallel. Times the height, that is AE. Okay, already we know AB as 10. We know AE as 5. What is left is FC. But what you should know is that for the FC is the addition of FE plus ED plus DC. This plus this plus this. That will give us the FC. Alright, so let's look at this side will be opposite to this side. Okay, because here is 90, here is 90. So this becomes what? A rectangle. ABD becomes a rectangle, so the opposite sides will be equal. So ED here will be 10. Here is even 5. Okay. So if that is the case, we know here is as 10. The ED here as 10 centimeters. What is left is this place and this place. So if you look at the triangle here and the triangle here, you realize that if here is 30, and then here will be 90. 30 plus 90, that is 120. So here will be 60. 30, 90, 60. So this triangle here is the same as this triangle here. Alright, it means that even this side will be the same as this side. That is isosceles trapezium. Okay, if that is the case, if I calculate for this FE, it will be the same as the DC. Because this side will be the same as this side. Because this triangle is the same as this triangle. Alright, but I'm giving the angle here as 30, and here is what? 5. So opposite, the angle is opposite to 5, and here is what? Adjacent. So I can use the trigonometric ratio, and then I find. Is that okay? So that I use tan opposite to adjacent, and I find here whatever I get here is the same as this side, because this triangle is the same as this triangle. Is that okay? Alright, so I will say that maybe from triangle AFE, triangle AFE, from this triangle. Alright, what I can say is what? Tan 30 degrees, tan is what? Opposite, is equal to 5 opposite over adjacent, FE. Twa opposite on adjacent. So if I want to find FE will go here and tan 30 will come here. Alright, so it implies that my FE, okay, let FE be equal to what? 5 divided by tan 30 degrees. Okay, so let's check 5 over tan 30 so that we know the FE. 5 divided by tan 30. That will give us 5 root 3. 5 root of 3 centimeters. Okay, let me use the root so that in my final answer I can write as decimal. Is that okay? Alright. So 5 root of 3. It means that our DC, okay, will also be what? 5 root of 3 centimeters. So this side is the same as this side. So DC will also be the same thing. Alright, so if I want to find, so let me find the FC. Therefore, my length FC is going to be what? 5 root 3 plus 10 plus 5 root 3. FE, which is 5 root 3, plus this side, which is 10, plus 5 root 3, which is this side. So FE plus 10 plus DC will give me what? Will give me the length FC. Alright. Okay, so let me write it answer in decimal. Because 5 root 3 plus 5 root 3 give me 10 root 3 plus the 10. So let me write it in decimal. That's going to give me 27.32 0.05 centimeters. All right, so it means that the length FC is 27.3205 centimeters. Then now we can find the area. All right, so therefore area of the trapezium will be equal to, we know the area is what, half times sum of parasite. So the parasite is AB 10 plus 27.3205 multiplied by the height, which is what, 5 centimeters, and that will become the area. All right, so we will have half times, what is 10 plus 27.3205, that is 37.3205 times 5. So this is how it is going to be. All right, so 1/2 times 37.3205 times 5 will give us 93.30125 centimeters squared. All right, 93.30125 centimeters squared. Okay, so that is the area. Now let's look at the perimeter. Okay, we are asked to find the perimeter, and with the perimeter is the distance around the figure. So we can say the perimeter of the trapezium, okay, will be equal to AB plus BC plus CF or FC, CF, okay, plus AF. All right, so what is the AB? The AB is 10 centimeters, and then the BC we don't know. The FC is what? The 27.3205, and then the AF too we don't know. But what we should take note that the BC is the same as the AF. All right, so we are going to find one side here or this side, and then what we are going to use, whatever value we have here will be the same as, because we already previewed that this triangle is the same as this triangle. All right, so let me say, you can say from triangle BCD, okay, from this triangle, if I want to find the hypotenuse, this side become the hypotenuse. So I can use what? Opposite on hypotenuse. So I can say sine 30 is equal to opposite 5. Hypotenuse is BC. All right. So the BC will be and the sine 30 will come here. So my BC is going to give me what? 5 over sine 30. 5 divided by sine 30 degrees. And what is 5 sine 30? 5 divided by sine 30. That is 10 centimeters. All right, so here is 10 centimeters, and here is also what? 10 centimeters. All right. Therefore, we can say that what? Therefore, perimeter of the trapezium will be equal to 10 here plus the 10 here, the BC, which is also 10, plus the CF, which is 27.3205. Remember, 5 with 3 plus 10 plus 5 with 3 will give us the 27.3205, plus the 10 also here. So 1, 2, 3, 4. So 10 plus 10 plus 10 is 30 plus 27.3205 will give us 57.3205 centimeters. 57.3205 centimeters. So that is what? That is the perimeter of the trapezium. Trapezium is so wonderful. You see how trapezium is? It comprises of a rectangle and then a triangle. Very simple like that, okay? I'll see you again as we solve more questions on trapezium. Bye bye.